Hi everyone, welcome to the second video. In the previous video, we have prepared a computational domain for both the node cones, and in this video, we will learn to import the geometry to ANSYS, prepare mesh for the geometry, and also perform name selection for the boundary surfaces. So for that, go to search bar and type workbench and open ANSYS workbench. So after it opens, make it full screen and scroll to the component system and find mesh. Now drag the mesh and bring it to the work area. Now inside meshing, right click on the geometry and you click import geometry and go to browse. And I'm already in the folder. So if you are not in the folder, go to the folder where you have saved the geometry. And let's first do for the conical Nosecone. And I'll also rename this by double clicking this conical Nosecone. Okay. So now let's go to the meshing by right clicking mesh and clicking edit, or just double click on the mesh. Now inside the meshing, geometry is already loaded. Now if we just right click the mesh and click update, it will generate a coarse mesh. It will generate a very coarse mesh actually. So I'd like to give a size to the mesh. So right click on the mesh, insert and click sizing. So let's select this filter. It is with this filter we can only select the body, and go here and click apply. We have selected one body and give this dimension to be 10 millimeter for now. Actually, this dimension should later be decided by mesh independence study. However, for now, let's go with 10 millimeters and update the mesh again. It will take some time, depending on the number of nodes and number of mesh. So the meshing is done. Now let's do the named selection. So we know that here we have our rocket body, and this is the ear outside the rocket body, and this is our inlet of ear. So for that, let's select the face filter. Select this face, right click and create name selection. Right inlet for this face. And also select all these other face by clicking control, by holding control button. So full faces, and select this face also. So these 5 faces, right click and create name selection and give the name opening to these 5 faces. So I've created 2 faces, inlet and opening, because I'm going to give inlet and opening boundary condition to these faces. However, it's not necessary that the name should be name selection should be same as the boundary condition. It just need to be a proper representation so that we can understand easily. But I can name it like inlet 2, inlet 3, or whatever the name I want. Now let's select these 2 faces and hide these faces so that I can see the remaining faces. Now let's select the Nosecone face. So we can see that the face is not properly highlighted as before, because this is the interior face. The exterior face is highlighted here. So right click this face and create name selection again. Select this face, right click this face. I think we need to select from the inside. It's because I am inside geometry. Yeah. If I click on geometry, it will give me the option create name selection and give Nosecone. Okay. And also click this and create name selection and give the name of body. So now let's go to the mesh again. Let's examine the mesh for once. So go to this section plane to create a section and make a line like this to visualize the mesh inside. So we can see that the mesh is almost the same throughout the geometry. However, to capture the boundary surface of the flow, we want the mesh near to this wall, the rocket body's wall, to be smaller than the far field. For that, let's apply inflation to the mesh. Right click on mesh and insert inflation. So I suggest you read about inflation because it will be out of scope of this video. So in the geometry, select this whole body as geometry, yes, and in the boundary, give the face filter and select the nose cone and body and click apply, and leave the maximum layers at 5 as 5 and growth rate as 1.2. So the number of layers, I will show this after the mesh is generated. So the number of layers means how many number of layers you want above the body that conform to the surface, and the growth rate indicates the ratio of the size of the later mesh to the earlier mesh. The meshing will take some time. So the meshing is done. Let's see the mesh. So as I said earlier, there are 5 layers now. 5 layers with growth rate 1.2. 5 layers, and each step the size of the mesh is increasing by 1.2. So we now prepared the mesh. So the mesh looks like this. We can also export the image of this mesh if we need it in our report. For that, we go to image and select image to file. Deselect this option, current graphics, and select high resolution, and select the white background. We don't want blue background for our formal reports. And I suggest you use some font magnification. I usually use 1.2, and select and save this to the same folder. Desktop. Yeah. So I can save as conical mesh. So I have not actually positioned this in the center because I don't need this image. I'm just showing such that you can do it if you require. See. So the meshing is done. So the basic unstructured meshing is done in ANSYS. So for more detailed meshing should be done for accurate results. So the inflation layers, the first mesh size, everything should be calculated on the basis of flow characteristics. However, for our application, this mesh is going to work. So let's save this file for now. I pressed Ctrl S. I will save in the same exact folder as Nosecone flow simulation, or you can save it with any name you want. It's saving the file. And I have followed the exact same steps for tangent ogee Nosecone and prepared the mesh of the domain. You can see this is the mesh of tangent ogee. So with exact same parameters. So in this video, we have prepared the mesh for both the Nosecone. We imported the geometry, we prepared the mesh, and we also performed the named selections. And in the next video, we will set up the physics of the problem using ANSYS CFX. Thank you and see you.